So, welcome to our new AT video about the hybrid system in Isabella's. So, I just want to explain a little bit more in depth how it works so that you can also replicate yourself if you like any kind of a proposal of how could off-grid the systems could work and then and how to produce energy in sustainable way. Well, as much as we can, you know. So when I came here, I found this wind turbine, which actually was built in Sunseed, in the workshop on the back here, and is built mainly from wood, some steel parts, and then inside there's some magnets, and then there is a concrete base that holds the windmill up. And I was really interested about seeing how much it produces and then how we can use the energy it produces, because I find it one of the most sustainable ways that you can produce energy in small scale for a household, because the materials are actually locally sourced, and then you can build it yourself and you can repair it yourself. It's based on a very good book that I'd always suggest, and I probably will put on the description, is the recipe book for a wind turbine by Pigot, and then by Pigot, and from a guy from UK, and then you can build it yourself as well. Okay, so the wind turbine I was talking about is about a 300 watt, so it's quite old and it's quite small scale. It was inspired by Los Portales, another eco-village in Spain, which they have much bigger DIY wind turbines, about 1.5 kilowatts, which supplies lots of the electricity. And so, going a bit deeper into the technical characteristics of it, I'm going to explain a little bit how it's connected to the batteries. So, just to explain, we're off-grid, so we're based on batteries. So this is a system of 24 volts, and I'm going to explain more or less how the wind turbine comes into the batteries. So how do we use the power that is being produced? So the wind turbine comes into the batteries with a three-phase AC. It's a very typical winding for a wind turbine and very efficient. Then there's a stop switch, so in case there's you don't want the wind turbine to work, you just put the two phases together and then it stops it from spinning. So if you want to repair it or there's a problem, you just stop it from there. And then it comes here, and then the three-phase AC becomes a DC, which is actually what we can use for our batteries with a rectifier. This you can very easily find on the internet. It's pretty cheap. So after that, we have a amperometer, just checking out how much voltage it produces the wind turbine at the moment, and then it goes directly to the batteries. But then there is a battery charger. There is a 3-star Morningstar 45 amperes battery charger, which controls the charging of the batteries. In this case, we have one for the wind turbine and one for the solar panels. The one for the solar panels is doing a great work on maximum power point tracker. So it tracks what's the best voltage amperes that the PV panels can give at each moment. What the wind turbine charger does is that it tracks when it gets over a limit of voltage, then it dumps the extra power to a dump load. And this is very, very important when you connect a wind turbine to a battery, because if you just let the wind turbine run on its own, it will probably explode the battery when they are full and they don't need more energy. And as well, you can't just turn off the wind turbine without a load, because it will also get broken. So what this guy does is that as we set it on a 28 volt, when it reaches this limit, it starts doing this nice sound like zzz, which means that it gives power back into the diversion load, as we call it, or dump load. I'm gonna explain inside what did we use here as a diversion load.
So in most of the applications I've found on the internet about the diversion load, it's just a load that heats up the air and the power is just dumped. But I got the idea when I was speaking from a guy from Recambio. You could actually warm water with the extra power that you get from the PV panels and the wind turbine when the battery is 100% charged. So I saw that we had an old thermal here in Sunseed, and then I ordered a low voltage resistance because what it's gonna get is a 28 volt. A normal AC heating element will not work because it gives very low power when it's worked on 28 volts. So I installed it inside, and then when it's 100%, and we can see it here on our meter, it gets hot, and then it gives hot water for the winter here, and then not only that, but I also ordered some AC heating elements so that they will give small power and so they will not heat up a lot. In order to use them inside here, so this is the hay box. So it's just an insulating box to keep things warm if you want them, or just slowly cook them. And then I put another 3 heating elements here in parallel, so that they reach, I would say, 35-40 degrees. So they're not to cook on, but they are keeping this place warm so that it makes the hay box even more efficient. So actually you can just play as much as you want with it. You can just mathematics. I mean, you can just imagine that you have a 28 volt constant coming in, and what you want to do with it, you can do whatever. You want to have it on the stove and let it slowly burn, and then I think it's a good application to have some hot water there just by the actually excess energy when the battery is already charged.
Good. So I think that what troubled me and what probably will trouble most of the people is that we have a hybrid system. That's how it's called when it's also solar and wind. And we have 2 different chargers controlling the same batteries. And so on the technical point, they have their own algorithms of how to charge the battery, and they can interfere one with another. So it's like it could happen that the one is pushing up the batteries and the other one is pushing down, so they are actually kind of eliminating one another. So in order to solve that issue, what I read, it was that the best thing to do is to put the diversion voltage a bit lower than the absorbing voltage of the solar battery charger, in order to allow this. Okay, you never let the battery go higher than the maximum that the solar charger says. So actually, you're making the life of the batteries a bit easier. So in our case, I played around the 27.7 voltage or 28 or 28.2, rather when the maximum voltage of the solar charger is 28.2. So you can play around with it. The only thing you need to keep in mind is that don't go too high for the batteries, and let them also have their cycle of charging. Don't let them go to diversion very soon, because it could actually need that you're tiring them and you're not using the excess energy. That's what we want. We want to use the energy that the batteries don't need. So the solar charger just stops the PV panels from giving power when that happens. But if you have this one, you can actually use both the solar panel excess and the wind excess. So that's it. Another project from the AT from Sunseed, and I hope you enjoy listening to us. And if you have any questions about the technical details, you can write to our email. And I hope more people are getting interested in the DIY wind turbines, which are actually getting more famous now that there is a lot of skepticism about how actually sustainable energy is being produced and which kind of materials are used in this process. Bye bye.